Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I am John Calloway.
I'm Clayton Hunt.
And I am John Ash.
With us today is Dennis Doomen. Dennis is on an everlasting quest for better solutions that will significantly improve the efficiency, the quality, and the productivity of your software development teams. Among other things, he is an author of Fluent Assertions, an API for asserting the results of unit tests in .NET. Welcome, Dennis.
Thank you. Thank you for having me.
So before we get started, would you just give us a little bit of introduction about yourself, maybe sort of how you got started in the industry?
Oh, wow. 21 years and counting. Absolutely. I actually don't know how I ended up in this business. I mean, I just like software development since I was young. I had a Commodore 64. Maybe you remember that. I had a Commodore Amiga as well and started programming in C and C++ at that time. Somehow ended up in the non-IT business, but yeah, I did a lot of programming outside my job, and then I decided to make it my profession. I have been doing this for, basically, as I said, for the last 21 years as a professional software developer, consultant. Last 10 years, I've been speaking a bit, doing some open source development, as you may have heard. And I enjoy my work. I'm passionate. Love to talk about it.
Awesome.
Yeah, and I was able to catch one of your presentations in Orlando a month or two ago on dependency injection and inversion of control. You want to maybe give us a high-level overview of what that talk was all about?
Yeah, it was mostly driven by the fact that I ran into a couple of architects, experienced ones, that were telling the teams, like, you should not use dependency injection. It's evil. It's going to hurt you. It's going to, bring your code base down. And then I started to think about, like, why is that? Why are people somehow rejecting something? And the same happens with object relational mappers, for instance. And I started to think about that, and I realized that probably everything is all of this whole, I would say, attitude or mentality is caused by the fact that they've misused something. I mean, every tool has advantages and disadvantages, and if you understand that, you also learn when something makes sense or not. And dependency injection is one of the examples that you can easily take the wrong path. And if you take the wrong path, it's going to hurt you. TDD is test-driven development is another example like that. So I started to think about, okay, what is it, what people, what frustrates them, or what are the pains of dependency injection, and try to come up with some examples that try to keep you away from that and make you successful, or at least, I would say successful, but at least allows you to solve the problem in the way it was supposed to be solved.
So what were some of the kind of misdirections that people are using sort of dependency injection and version of control for? They were using it.
Yeah, it's a good question. People say stuff like they hide the magic. You don't actually understand, or it's really difficult to reason, like, how does an object get resolved and how do the dependencies get in and where are they registered. They say that it forces end up in situations where all your unit tests successfully complete, and then when you run the application, stuff start to fall apart because you've never actually verified that your registration code is doing what it's supposed to do. They also say it's not always clear when your dependencies are created and when they are disposed, for instance. Stuff like that. Or they cause diamond dependencies, or the unreadable bootstrapping code. You may have seen those pages and pages of registration code. That's kind of the thing. Oh yeah, and there's one, of course, the overzealous faking, and maybe I don't do a lot of fakes anymore because I've changed the way I work these days. But you also see that quite often that people create a class and then they create the whatever class of interface next to it, and people all blame this on dependency injection, which I think is not fair.
Yeah, and you had some interesting ways around that so that you don't necessarily just automatically create a given interface for the implementation class that you've already written. You were using delegates and some other language features. Is there a way to discuss that without using visual aids?
Well, I would say it's not necessarily about delegates. Although there's one of the examples that we discussed, I think, is that somebody takes a dependency on a func of something, and typically that happens because a class wants to be able to decide when it creates an instance of that dependency. It's kind of a factory implementation if you try to include design patterns. Trying to figure out how that func gets resolved or how that thing gets registered in your container can be pretty complicated. And one of the examples I think I gave was to define a delegate, a named delegate. One of those C# features that, and I see everybody shaking their head now in the video, which the listeners can't see, is a C# 1.0 feature where you basically define a signature. Maybe you want to be able to resolve, let's say, an order repository or something. You just define a delegate with the name get order repository, which gives you that iOrder repository, and you can actually register that somewhere. The cool thing about the delegate is named; it's a type in .NET, so you can use your whatever tool, Visual Studio or Writer or whatever tool you use to figure out where it's actually registered, which is much more difficult with funcs and actions and stuff like that.
Yeah, I don't think a lot of people know this because they're not too familiar with delegates, but I mean, really, func and action are just Microsoft provided generic delegates.
True.
I mean, they're just here's a delegate that we've made because we know it's common, and it has 16 different parameter placeholders that you can use.
Yeah, it's true. If you look at the decompiled sources, it's incredible. Oh, even if you try to look over the overloads, it's true. Yeah. But yeah, in a way, a named delegate is exactly what it says it is. It's a named delegate, something that captures the intent of that thing, and it's very discoverable. That's one of the little tricks I use a lot.
Yeah, and one other talk or presentation that I saw in your library of talks that you do in and around the community was something around building libraries and not frameworks.
Yeah.
Do you want to kind of give us a high level overview of that one? Because just the title alone really resonated with me.
It's true. It's again trying to solve a problem that I've been trying to solve for years. And the thing is that when you start developing, you become fluent in your language, and at some point you reach a point in your career where you have to work with people that you could say lesser goals or lesser experienced people. And what you're trying to do is reduce complexity. And one of the things a lot of people do to reduce complexity is to create abstractions, because working with abstractions generally means that you don't need to understand the details. So what happens is the abstraction is changed into a framework, because the framework is supposed to solve a common problem. This seems like it works, and usually it works for a while, until you run into a situation that you need to support something that the framework doesn't support out of the box. And then you start to figure out, okay, how do I actually make this framework do what I want to do? And you start to go into the details, and then it becomes ugly. Some things are too complicated. You should never want to be able to go into the details. But generally, frameworks try to abstract a pattern. And if the problem that you have does not meet the pattern, you're kind of stuck. And I've learned that over the years, and again, 20 plus years, that framework is probably not always the best solution. Maybe it's actually better to build a library that doesn't hide the magic and kind of forces you to understand what you're building. Because in the end of the day, the framework will enable something, but I mean, requirements change, at least in my world. The requirements change all the time. My product owner changed his minds, and at some point you need to understand the details. So I've started to organize my systems and whatever I build, libraries, systems, around building blocks that solve small problems, and eventually, if you combine them, they solve the bigger problems, instead of trying to come with this super component that tries to solve all your problems until they don't.
Yeah, my favorite is the companies that are going or attempting to go to microservices, and they have a monolithic framework that they built and say, oh yeah, just use this framework for this new microservice that we need. But the microservice is literally one method, and you're asking me to download a 6 gig library for this, or 6 gig framework for this. That just doesn't make any sense.
Well,
Yeah,
you have to
that's
have.
one of the that's true. That's one of the side effects or advantages of a library instead of a framework. But of course, a library, if you build it like that, also means you need to really understand all the details. You need to understand the nitty gritty of how the thing is supposed to work. So the learning curve is, I never know what it is. Is it more steep, or is it more? It takes more time to become productive with it. As soon as you are productive, you may be able to solve different problems that you didn't expect that library could solve for you.
Do you have any thoughts or opinions or just tips and tricks to developing a library? Like, how do you find that sweet spot in delivering just enough, but not too much, and maybe not breaking it up into thousands of microscopic libraries into, this is just enough for logging or something like that?
Well, it's interesting that you say that, because I do have some principles that I follow. And for the record, I didn't invent them myself. Robert C. Martin talked about that for the last 20 years. But the principles that I follow actually cause you to end up with more packages. But the idea is that you have like a main package, you could say. The main package contains, you could say, a bunch of classes. Each of those classes can be used directly. They each solve a specific problem. And then usually you have some convenience classes on top of that combine those building blocks in a way that solve common problems. But the point is, they should not use inheritance, which could be difficult to do. But I actually favor composition of inheritance. It's a bit of a dogmatic thing, I would say. But by defining your package of small components, there's a bigger chance you can reuse them. The other thing is that you need to be careful that anything that's not in the main package, or that, sorry, you need to cut. Somebody actually walked into the room. Sorry.
No problem.
Let's try again. So the main package contains building blocks that are usually used together. Anything that's in that main package that is not always used with that main package should be moved into a separate package. I call it an auxiliary package. This also prevents or avoids situation that you're going to change one class of that package, resulting in a new version, even though like 90% of the package hasn't changed. So you're trying to avoid unrelated changes leaking through to your main package. It's kind of the single responsibility principle, but then on the package level. The same is like your package should not depend on anything that's less stable than you. You should only depend on stuff that's more stable than you. Because if you depend on something that's more stable than you, then there's a lesser chance that you have the ripple effect that we all know and the DLL hell. So depending on, for instance, in the .NET world, we all know maybe the Owen library, which has had one version and I don't know, 140 million downloads. That's fine. Depending on maybe something like Mutisoft, .json, which seems to have like 3-4 breaking releases per year, is not a smart choice here. Yeah, it's a bit difficult. You really need to see the picture, of course. But and one extra is if you depend on something like if your package can work with, I don't know, external things. Let's say you have an ORM that supports an Hibernate or anti-framework, you should actually not add a dependency to an Hibernate on your main package, but you should have an extra package that tries to connect the two. Does that make sense?
Mm-hmm.
I see people trying to create a mental picture of that, but
well, those are all the extended versions of the solid principles that Uncle Bob has defined. I can't remember the names of all of them, but it's common reuse equivalency principle and stable abstractions principle and a few others. I feel like they're the solid principles, but on a much larger scale. And
on package level, you could say, or component level, maybe even.
Yeah, and it's difficult for people to grasp the solid principles at the level that they're intended to be applied, and so it's even more difficult sometimes for them to grasp the package principles or the module principles.
Yeah, that's true. In one of my slides, I have a slide that tries to capture it. I always use that as an example because it helps create this mental picture. But you're right.
You keep saying package, which is relatively new term for .NET engineers. Normally we think libraries or projects. When you say package, does that mean that you are separating things out into separate NuGet packages, or just other projects, or even other folders within the same project?
That's a really good question, actually, because it's all of the above.
Okay.
So initially, the presentation that we just discussed was about separating your code into individual NuGet packages, which maintain dependencies or control dependencies. But I've also seen that the same principle can also be applied to a single solution. Let's say you're building a big system. You can define projects and really think about what should be in a product, what should be a separate project and what not, and how do you combine everything. But I personally believe, and I think Jeremy D. Miller once mentioned this in a blog post like 8 years ago, I don't create projects to control dependencies. I only create separate projects because there's a deployment concern. So what happens is that the same principles are now applied within the project, within folders within the projects. So what I try to do is kind of feature folders. I break down my code into folders that represent functional or technical features, and then I really try to prevent creating connections between those folders unless it was designed for that. It requires a lot of discipline, to be honest, but the same principle applied as well.
Awesome.
Yeah, there's been some discussion recently on a number of projects that I'm involved in about combining a lot of repositories into like a large monolithic repository. Also read about the same in the DevOps handbook. But like you said, it does require a lot of discipline, because there's nothing preventing an engineer to reference something in a folder that you didn't necessarily intend for them to have access to.
Yeah, and that's really easy with tools like Resharp, or it's a simple Alt-Enter and you have the connection. Yes. Well, that's where we have pull request reviews, but obviously it doesn't help that much. You can see it from the namespaces. But merging different projects into the same repo would also mean for me they have the same release lifecycle.
Mm-hmm.
That's also important, because I also mentioned in my presentation that great libraries have a clear release strategy, semantically merge versions, stuff like that. That's also part of that. If you merge them, then they must have the same release cycle. But usually if you break down something into small NuGet packages, they probably have differently release cycle. That's why you want to separate them.
Do you, when you're working with your teams, do you have issues, or have you worked through sort of getting everyone to follow those disciplines and getting people on board? Has that been an issue?
They just do exactly what I want, and they fully understand my mental models all the time.
Okay.
All right, let's spend the next hour talking about how you
Yeah.
It's really hard, because I look at the thing is, a lot of developers have the tendency to dive into the details and get, I don't know, they get swallowed in the details. They get swamped. I think that's the word for that.
Mm-hmm.
And they are trying to make something, to get something to work, and then they forget like the big picture. Like, where is this little thing supposed to play a role? What is the boundary? This is the most difficult thing, I think. And I use the word boundary a lot these days with my teams, because it's really difficult to figure out or create a clear picture of what are the boundaries within your system. And the boundary is also the boundary, defining the boundaries of your package, but it is also the boundary of a feature. And if you include TDD, for example, the boundary also defines the scope of your tests that you're writing. And that's really difficult. And it's not just difficult, it's also open for debate quite often.
Yeah, I often get caught, I guess, because the rules from the business are not always clear as to how the application should be broken down. So I try to start with a minimalistic solution in an attempt to understand the flow of the application before I break it up into its individual pieces and figure out what pattern is going to be best for this application. But then all the other devs that aren't also thinking that same thing jump in and they go, oh, look, a pattern. And they just replicate whatever terrible thing I have done throughout the entire system before I have a chance to stop the spread. And then it's just chaos for quite a while.
It is, and I see that quite often. Like I'm looking at somebody else's code base, I'm looking at a solution, and I wonder, like, why are we doing this in this way? Why are we not actually looking or reconsidering the, I don't know, the scope of the test or something like that? And then the answer is, yeah, we always do that. Why? Yeah.
Yeah, because that one person
Why?
did it that one time.
Yes, somebody actually thought about that, and he probably had a really, or she, a good reason for doing that. But yeah, that information gets somehow lost in translation, or I would say lost in the noise of commits in your GitHub repository.
Yeah.
Yeah.
Yeah,
I tend to do that quite a lot. I tend to sometimes take some time, look at the solution. It makes me a bit slow in from the productive side, but I reserve time to reconsider or look again at the big picture.
Yeah, well, that's what ends up happening is I'm forced to spend 3 weeks doing something that another developer would spend, a day doing.
Yeah, and then the next time somebody says, "Oh, don't let Clayton do this because it will take you
Yeah,
more time."
he's horribly slow.
Yeah, I recognize that.
Let's switch gears just a little bit since we've mentioned TDD and testing a number of different times, and wanted to touch base on you're the author, the originator of the Fluent Assertions library. Do you want to tell us a little bit about that?
Fluent Assertions, yeah, it's a little project of mine, moderately successful, I would say. I don't know. I like Fluent APIs for some reason. It was started at the time that we just had MS Test, I think. XUnit and NUnit were not that popular yet. And it's essentially an API to make your test a bit more readable, especially the assertion part. Because I strongly believe in unit tests. And again, unit depends on the boundary, but I strongly believe in automated tests that have a clear cause and effect. If I look at the unit test, I should be able to figure out first from the name, what is this thing supposed to do? What's the functional scenario? And then I look at the implementation. And that should also be really clear. What's the entry? What's the starting situation? What is the action that's being executed? And then what's the error that happens? And again, I can quote Jeremy Miller here. He once said, like, you should be able to keep out of the debugger hell. So I kind of started Fluent Assertions so that if a unit test fails, it gives me really clear message, like what's going on there. And I also don't like repeating myself. So over the years, some APIs have evolved or emerged that allow you to compare entire object graphs and also emphasize the parts of the API that is really relevant. It's really difficult to explain that, by the way, over audio. You have to actually see the API and the syntax for it, and especially the failure message if something fails.
I find the method that I use the most is class is or should be equivalent to another class.
It's one of those. It's really powerful, but it's almost like a framework. Sometimes you need to understand the magic to see what's happening. I fully realize that. Yeah. It allows you to compare two object graphs, even though that they are not the same type. Mm-hmm. It's really beautiful to compare against the anonymous type, because then you can actually say this object should match this anonymous type, but only include the properties that you care about. And it's really smart about how to deal with collections. By default, assumes collections are unordered. It will also try to give you really clear details, like when two collections are mismatching. It's a pretty powerful thing. Yes, absolutely.
Yeah,
I imagine that it started primarily with .NET Framework. You said with MS Test.
Yeah.
I've been using it in .NET Core with XUnit. So how has that evolved over the years? And do you have a lot of contributors, or how do you manage that project?
Sorry. It kind of started, the project started, I don't even remember when, probably in 2008 or something, together with a colleague of mine, Martin Oldam. And as every open source project starts, it's usually something you try to fix for yourself and then you extract it. We had quite some breaking changes over the years. We're now at version 5, but it was a nice learning school to understand how to deal with the versionability of APIs and how to deal with that. Contribution-wise, I don't know exactly when it started to really kick off, because these days it's like 1 million downloads a month or something. But in the beginning, it was mostly me and Martin, and then here and there some people started to join. Especially when I moved from Codeplex to GitHub, things really became to change, because Codeplex, you had to deliver a patch that never really worked. I also never had to support multiple versions at the same time. People were generally willing to upgrade, and I also consciously tried to postpone all my breaking changes until the next major version. There's a couple of people, Oren Novotny, maybe you know him. He's the React guy. He helped me a lot supporting PCLs, portable class libraries. I think, no, we actually started with copying files, using linked files, because we had to support different .NET frameworks. And then we had to support MB unit and X unit and N unit, and I don't know how many other units we have. Then we moved to PCLs. And then I think later we moved to shared projects. You can also see that the project actually evolved with all the Visual Studio and .NET versions and all the platforms around it. Especially Oren helped me a lot with the PCL part, because he knew all the PCL numbers by heart. And he said, you have to do a PCL 457. They're like, wait, what is that? Yeah. And then the shared projects came. It was still a bit of a, I would say, pain to support all the frameworks, but everything became much nicer when we had these new cross-compilation things in the latest .NET versions. Makes it a lot easier also for people to contribute. And you can see that. There's always a couple of pull requests available. Yeah. But it comes with a cost. I mean, you also have to sometimes say no, because people want to add extensions and you don't want to support that, or makes it really difficult to extend that, or to keep the system or the API consistent.
Yeah. Is the community understanding when you have to have those conversations, or when you have to decline or say no to those types of things? How supportive is the community around this project, I guess?
It's a good question. I would say generally, yeah, people are pretty supportive. Because I also sometimes get like a pull request, and then somebody's already like, yeah, I realize it doesn't really fit into the existing API really well, but maybe we can have a discussion about that. Slack also helps, because sometimes the discussion starts in Slack, like, hey, you know what, I want to support something like that. Would that be possible? Yeah, I would say yes. I didn't have any fights. Maybe people don't respond anymore to the. But generally, I would say it's really nice. It's a really nice community behind that. Absolutely.
Yeah, I'm gonna have to check it out. It's new to me, so I enjoy unit testing, and we do it pretty heartily, and it sounds like it could really help us. So
yeah, I think I tried out Fluent Assertions 2010 to 2012, somewhere around there. At the time, I was experimenting with different libraries and stuff that could help me with testing, and I actually didn't stop using it for any like real good reason. I stopped using it because of the word should. Is a little bit of a wiggle word, and there was quite a bit of talk going on at the time about how don't use should. Should's old. Don't use should. Just say the thing it does this, and then if the test fails, it's because it didn't do that.
Yeah.
And then
at some point, I even considered, and we discussed and we've checked if it would be possible to allow you to use the word must instead.
Yeah, I think it may not be a C# library, but I think something does use must, doesn't it? Maybe it's a JavaScript thing.
Could be. So these days it's mostly me and Jonas Nierup, which obviously I never met. He's doing a lot of work. He's pretty critical on the code reviews. It's a pretty static thing. It's kind of feature complete, but people always come up with new ideas of how to make it nicer. It's also more difficult because you really have to think about backwards compatibility, especially all the overloads and stuff like that. That really has caused us some issues. Like recently, we released a version and we did some internal refactoring, and we never anticipated somebody to use your library in a way that they were using it, causing like binary compatibility issues. Yeah, it's also because there's quite a lot of extension or libraries that now extend Fluent Assertions and provide that. This is something I never realized.
Yeah, it sounds like a really good experience in designing systems of that scale.
Absolutely. I mean, I learned about pull request. I learned about designing systems and APIs. I learned about quality guidelines. I also because I'm a kind of a C# coding guidelines guy. I have my own guidelines for the last, I don't know, since 2001. It's also, you need to find, kind of a middle ground between what do you expect from contributors in terms of quality level. Are you willing to do some cleanup afterwards just to, make it easy? It's something I've experimented a bit. There's quite a lot of literature on this as well, of course, but yeah, I try to be accommodating as well. Yeah. And I was just checking while we talked about this project, was looking at the GitHub statistics, and I didn't realize, but there's apparently 281 forks, and I had 104 contributors. So yeah, not bad, I would say. Very happy with that.
So a significant portion of our listeners are sort of more junior, or they're looking to sort of either get into the industry or kind of really grow themselves, step into kind of bigger roles and grow in their responsibility and approach of things. So do you have any advice or words of wisdom that you might be able to sort of target them specifically on how they're just getting started, and or how to kind of what should they focus on to really advance themselves?
That's a really good question. I wish I had some time to think about that.
Okay.
I would say the thing is, our profession is too broad these days. There's too much stuff to learn. I would definitely avoid trying to say I want to become an architect because that's where the money comes from, or I want to become a manager. It just happens magically. I would say participate in open source projects, because there are kind of, and I don't think it applies to all projects, but I would say an open source project could be a nice environment where you can learn from others. I mean, especially if you're in a place where you don't have any senior people, to learn from, and that happens to a lot of people. An open source project can give you a different perspective on it. I also think going to like meetups, like user groups and stuff, is a really nice place to share experiences. Even if you're a junior or something, at least you can hear other people talk about what they think are ways of solving problems. And don't take it for granted. Don't take it as the absolute truth. Don't take anything I tell you in this podcast for as the absolute truth, because something that doesn't exist. But understand different ideas and opinions and put that in your, mental backpack or something. So by the time you need to solve a problem, you may remember like, hey, I've heard this guy talk about that, or this girl or whatever, and maybe this could be a solution for my particular problem. But don't focus too much on trying to keep up with everything. Just listen and observe and try to spar with other people. Again, yeah, it's really difficult to give generic advice, of course, but yeah.
No, that sounds excellent. I think that was really, really good advice. Do you have any resources that you might point people towards for like whether getting into dependency injection or trying to build, trying to figure out how do we build better solutions, that sort of thing? You mentioned like Robert or Martin. We've mentioned a number of people, but
yeah, obviously Robert C. Martin has been an important source. I mean, the guy has been around for years and he gets a lot of criticism these days, but the stuff that he wrote is still so valid. So Robert C. Martin's book in general, Martin Fowler also wrote a couple of books which really are still completely accurate. Everything they say still applies to our job. I would also say Michael Fetters, he wrote a book about dealing with legacy code. Especially his characteristics test is something that everybody forgets about, but I still find is really useful to, start with unit testing on an existing code base. Yeah, it's a bit of a plug, but my, sorry. My own blog, obviously, I try to capture my own experiences because I use my blog kind of a way to, essentially compile things I ran into and something that I can remember for the past. Who am I? I don't know. I don't have that many different specific people that I really follow. Jeremy Miller, I would say definitely Jeremy D. Miller, the author of Structure Map and a couple of local libraries, has written a couple of really good articles. I think they were called like Jeremy's First Law of TDD, Second Law, that really kicked off my interest in TDD. And all of them are still completely I say that, applicable in the current state that we are.
Excellent.
Yeah.
If people wanted to follow you, other than obviously your blog, is there any other places or ways that they would be able to do that?
Twitter, of course, my Twitter ID. I'll share that. It's Doomen, which is difficult to say. People probably don't know how to spell that.
We could put a link in.
Yeah, of course. If you want to improve the level of your coding guidelines or your C# language, you can check www.c#codingguidelines.net, I think. And I'll share the links as well. It's a forkable repository to create your own coding guidelines. But generally, I mean, Liquid Projections is one of my recent projects, which is for event sourcing business systems, is a library that I really tried to build with this whole, dependency management principle in mind. I started with that before I started to think about that, but I really redesigned and extracted everything as a kind of an example for that. There's quite a lot of resources for that.
Yeah, excellent. No, that's all good. And I guess lastly, do you have any upcoming speaking engagements that you might be able to plug?
I had a bit too many speaking engagements this year, so it's a bit more quiet next year. I do a talk on the DDD exchange in London in June, and a couple of local things in the Netherlands, but no big things planned anymore. Not yet, at least. I might change my mind.
Okay.
Yeah.
Awesome.
All right. Thanks, Dennis. This was a lot of fun.
Thank you. Thank you for having me. It was an awesome experience.
That was Dennis Doomen. Dennis is on an everlasting quest for better solutions that will significantly improve the efficiency, the quality, and the productivity of your software development teams. And among other things, he's the author of Fluent Assertions, an API for asserting the results of unit tests in .NET.
If you liked this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I am John Ash.